My name is Holger Schmidt. I'm a distinguished professor of electrical and computer engineering at UC Santa Cruz, and I work on single molecule detection on a chip. Well, the original starting point was to answer the question, can we guide light through a hollow channel on a semiconductor chip? As we had successfully addressed that question, we were starting to look for applications, and testing especially biological samples in these kind of small channels was the natural next step. And what we've been working on for quite a long time now is to develop optofluidic devices that excite individual molecules like a nucleic acid, a DNA molecule, or proteins, antigens, and then collect the optical signals that they produce and detect them one by one, thereby simplifying a lot of the methods that people are using right now for medical diagnostics. Currently, in order to detect different biomarkers, you have to use different physical instruments, like nucleic acids are detected with a PCR machine, and then proteins are analyzed with what's called ELISA or chemoluminescence and so on. One thing that our device does, it can analyze both types of particles in the same run even, as well as completely different things like a whole virus particle. Another thing that's very important is to look for multiple diseases, let's say, or different cancer biomarkers at the same time. And so we came up with another optical trick by creating different light patterns with different colors. And so then when a particle runs through that pattern will be imprinted on the signal that we read out, and that's called multiplexing. You know, the point where we were able to test real samples from our collaborators and see individual, in that case was Ebola, RNAs one by one, there was a major breakthrough that was clear that this is something potentially useful beyond the research lab. We have worked a lot with infectious diseases, hemorrhagic fevers like Ebola virus, Lassa virus, also influenza, of course COVID, and Zika virus. But we've also looked for cancer biomarkers, and so that's another big area where these kind of devices could come in to detect early cancers. You know, I've really been lucky that I've been able to talk and work with some really great colleagues here at UC Santa Cruz. Really, the environment also shapes the opportunities and the new things that will come out, and that's a really great thing.